Hello YouTube family, welcome back to my channel. Today the problem that we are trying to solve is LeetCode 1984. It's an easy mark problem, and the problem says minimum difference between the highest and the lowest of k square. So we are given a nums array and a k, that is an integer variable that has been given. We need to find k number of groups in the array where the highest and the lowest element is minimum. So just to understand the problem, we are given find group of k elements. So over here 9417, 94 is 1k, like one group, then 41 is another group, then we have 91 is another group. So this is how we have to find all the groups. Then we have to subtract highest element with the lowest element. So in each group, suppose 91, we need to subtract. These are all the groups that are possible. 9417, 94 is one group, 91 is another group, 97 is another group. Then we have 41, 47, 17. Then so these are the all possible groups of k equals to 2 in this given array. So one thing that we need to understand is how we can solve this. First is finding all possible groups, that is over here. We have mentioned all the possible groups over here, but what will be the complexity of this? We'll come back to the complexity. First let's jot down what the brute force solution will be. Finding all possible groups, finding maximum and minimum in each group. Suppose 94, what will be the minimum, what will be the difference over here? It will be 5. Then over here it will be 8. Over here it will be 2. Then over here it will be 3. Over here it will be 3, and over here it will be 6. Minimum of all this is that 2. So we need to find this as an answer. We have found the maximum and the minimum in each group. We have subtracted those, and we have to return the minimum difference that we need to return 2. Now coming to the complexity part of the brute force solution, if we go ahead and see finding all possible groups. So if you have studied permutation and combinations, we've been given a formula NCK. So that is n factorial divided by n minus k factorial into k factorial. It turns out to be complexity of O n to the power k with the constraint given as 1000. 1000 to the power of 1000 is 10 to the power 3000, which is way more than 10 to the power 8 limit of ours. So how can we optimize this? If you'll think properly, what is our problem? Our problem is not to find all the given pairs. Our problem is to find the highest and the lowest in group of size k. And whenever this highest and lowest comes in the question, I think of only two things. One is sorting, second is binary search. Now if we need to find the lowest element, I go for binary search, but over here we need to find the difference of highest and lowest. What do you think can help us? So suppose this is our problem 9417. If we sort this out, do you think any two adjacent elements in the sorted array will always have the minimum difference? Am I correct or not? So if you see 14 and 47 will always be like 47 will always be less than 49, because 49 is comes like 9 comes later than 7, so 47 will always be minimum. So am I right in saying that if we sort the list, we are left with only 3 possible pairs, 1 4 4 7 and 7 9? Then we what we have to do for all the care, like we have found the sliding window approach. just remember sliding window. We have this window that we are sliding one by one. So we take the window length is k. We start from the first element, we go to the k element, and then we find the last element will be our maximum in the k slided window, in the window, and the first element will be the minimum. We just need to find the difference between the last element in the window and the first element. So if we find, suppose this is the window, difference between 4 and 1, that will come out to be 3. Then 4 and 7, that will come out to be 3. Then 9 and 7, that will come out to be 2. And we just need to find the minimum of all this. So that becomes our 2. And what will be the time complexity? Because we are sorting it, it will be n log n over here. And then later on we are applying the sliding window approach. So for this it will be O of n. So, and n plus n log n will be over here, n log n only. So this will help us solve this solution in n log n approach, which is very much acceptable in the given constraints. So let's try and jump into the solution part of it. So let's jump into the solution part of it. As discussed, first we are gonna sort this given array. Then we need to keep an answer variable that will store our minimum. So to store our minimum, we need to initialize it with the maximum possible, so float infinite. Then for I in range, length of nums. But do you think it should go to length of nums? What we are doing, we have to go 94117, but we need to do the sliding window approach. Over here it is sliding window. So in sliding window we go till k length. So if we'll see in terms of over here in the comments, if the length of nums is 4, k is 2, then it becomes what, 2. But so if we have to select any two variables, we have to go till 1, no? 9 4 is one pair, 4 1 is one pair, and 1 7 is also one pair. So we have to go till 3. That's why we do +1. I'm just trying to explain you why I've added +1 and how you can do this in interviews. Then we have to initialize the answer is equals to minimum of answer, then nums I plus k minus 1 minus nums I. Now just to help you understand, we are given 1 4 7 9. What we are doing over here, nums I, so and I is equals to 0 right now, and what we are doing is we have to do with this pair. So 0, that is nums I, of course. So nums I is equals to 0, that is 1. I think everybody will be clear about this. But what is this? This is I plus k. K is our window length, that is 2. So 0 plus 2, what it becomes? 2, right? But do you think what will be the 2? 0 1 2. 2 will be 7, but we need to find it for 4. So 2 minus 1 4. So it becomes nums of 1 minus nums of 0. That is how you need to explain it in interviews, so that interviewer knows that you are just not mugged up the answer but actually know it. Let's see if this works. Nice. And let's try and submit it. Great. So you can see it has got passed. I hope I was able to help you understand this solution. See you tomorrow.